A small spacecraft approaches the midpoint between two large asteroids that are far from any other objects. There is zero thrust exerted on the spacecraft from the spacecraft's engines. The mass of each asteroid is much greater than that of the spacecraft, and the distance between the asteroids remains constant. As the spacecraft approaches, which of the following describes the changing gravitational potential energy, delta UG, of the asteroid spacecraft system, and includes a correct justification. Let me try to draw a rocket here. Okay, this looks horrible. Anyways, remember this. When you get closer to this point, which is the equilibrium point, recognize that kinetic energy is maxed, and gravitational potential energy is going to be 0. This is because, well, if you are further away, like over here, there's less kinetic energy pulling you towards these two planets. And when you get closer over here, the planets are pulling you harder. And according to conservation of energy, kinetic energy, if there is more kinetic energy, there is going to be less gravitational potential energy because energy is going to be conserved. However, we have established that at this point, equilibrium point, delta UG is going to decrease. Because again, it gets closer to the equilibrium point where kinetic energy increases at the equilibrium point when it is maximized. Let's try to see whether it does negative or positive work. Here, it is going to do positive work, and you may ask why. Because if you look at the work equation, it is negative potential energy. Hence, as potential energy decreases, work is going to increase. So, because of this, the only logical answer is B.